Now, titration is based upon many things. You can have an acid-base titration, you can have a oxidative reductive titration, lots of different kinds of titrations. But a titration in general is an analytical technique to determine an unknown quantity. It's a very generic technique. In school, we frequently do an acid-base titration. Acid-base titration is based on an acid and a base neutralizing each other. When they neutralize each other, we form water and the leftover pieces from the acid and base, which is called a salt. For example, if we took hydrochloric acid, strong acid, plus sodium hydroxide, strong base, these are going to neutralize one another with the H and the OH forming water. And what's left over is sodium chloride, common table salt. So acid, base. Now, if there's equal moles of H's and equal moles of OH's, then we have none of those left over because they've all been formed into water. Okay, so these guys here form the water, and then these guys form the salt. Now, additionally, if the moles of H and the moles of OH are not equal, you're going to have leftover H's or leftover OH's, depending on which you have more of. Because when it forms water, it's a 1-to-1 ratio. Okay, and remembering, so when that point is reached, where it's equal and equal, that's called the end point. In an acid-base reaction, that pH is equal to neutral water, which is pH of 7. Okay, so we have moles of acid, moles of base are equal at the end point. Now remember that volume times concentration equals moles. Volume is in liters, concentration is in moles per liter. And when those are multiplied together, the liters cancel, gives you moles. So we're going to use this relationship to determine H's and OH's. So what we're going to do is we're going to have the volume of the acid times the concentration of the acid gives us moles of H. And the volume of the base times the concentration of the base equals moles of OH. Now, typically in an acid-base reaction, so how many, first of all, we have 4 variables. We have 2 concentrations, 2 volumes, 4 variables. That means you can leave out one of them and calculate it if you know the other 3. But you always have to know 3 of the 4. If you don't know the 3, you cannot do anything with this relationship. Okay, so we're going to be using something called a burette. And it's a glass tube about this long with a valve at the bottom. And inside that burette, now the purpose of a burette is to measure volume. Down here, we've got an unknown quantity of acid. We don't know its concentration. Okay, we do know the concentration of the base. That's going to be in moles per liter. This measures milliliters, the burette. So once we know the milliliters that neutralize the acid below, we can calculate the moles of base. So moles of base so liters from the burette and concentration from the burette. That will give us moles of OH. Now, that equals the moles of acid it neutralized. Okay, now remember I said we need 3 parts to the 4 variables, okay? So we've got 2 of them. That's from the volume from the burette, concentration from the burette gives us OH. H gives us down here at the bottom for the acid. So we know the volume of the acid we put in there. We'll put in like 20 milliliters or 25, something like a known volume. But what we don't know the concentration of the acid. So the goal in this is to find an unknown acid concentration. Now your lab is in 2 parts. First part is to calculate the concentration of your base. So you're going to start off with around 0.1 moles per liter of your base, and then you're going to get it exactly to 3 decimal places. The second part of the lab, when you come back, lab 16, is you're going to take a tablet and figure out how many milligrams of vitamin C, citric acid, is in there. So it's in 2 parts. You're going to hand them in, you're going to combine them together. So there'll be 2 pre-labs, 2 conclusions, and this can be worth 20 points, not 10. Okay. All right, so let's look at the calculations now. All right, so the goal in this, on these problems I'm going to show you, is to find the concentration of the unknown acid. That's the goal. So what's the acid concentration? What's the acid concentration? So the goal is acid concentration, okay? So we're going to make use of the moles equals concentration times volume for each of those. So we have at endpoint. That means they're perfectly balanced. Now, we need to know when that endpoint is reached, because we're only putting in drop, 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 drop of base, and we're not going to know till we get to the neutralization point. So the indicator we're going to use will tell us that. So we're going to have in our solution an acid, unknown acid, plus an indicator. The indicator's purpose is to tell us when we have equal amounts of acid, equal amounts of base, when they're equal. That's why it's called an endpoint. Okay, so let's so remember, the volume is always in liters. So once you find out how many milliliters of base it takes, you need to convert that to liters of base. Same with the acid, liters of acid. So in this case, it says 23 milliliters of 0.45 molar sodium hydroxide. So we have volume and concentration of the base. And we've got the volume of the acid, but we don't know the concentration of the acid. So now we can put our equation together. I'm going to use this one here. So moles of acid, volume times concentration equals moles of base, volume times concentration. Yeah. And if it's not in liters, you convert it to liters. So if it's milliliters, you convert it. Moles per liter. That's why when you multiply the volume times moles per liter, the liters cancel out, leaves you with moles. Okay, so we have four variables. The volume of the acid and base, concentration of the acid and base. So we're trying to calculate the concentration of the acid. So we want to solve for this. So Ca is equal to Vb Cb over Va. Okay. Four variables, we know three of them. Calculate the fourth one. Okay, so the volume of the base. Volume of the base is 23.4 milliliters. So that's equal to 0.234 liters. Because there are 1,000 milliliters in a liter. Okay, and so this is the volume of the base. Volume of the acid is oh, 25 liters. Okay, so what's left over? Concentration of the base. That's 0.45. Okay, so we have all of our numbers. Okay, the volume of the base is concentration of the base is volume of the acid is so the liters cancel gives us moles per liter. So the unknown concentration of the acid is that. A lot of little parts to titration. So the actual lab will go like this. We fill up our burette to the 0 mark. That's at the very top. Then we start, and then at the bottom here, we've got 25 milliliters of acid, 25 milliliters of water, which does nothing. It's just there to dilute it. We've got an indicator, and the indicator we're using is something called phenolphthalein, which is a very common acid-base indicator. Now, the purpose of the phenolphthalein is to tell us when we have neutralization. And it'll go from colorless to pink, a really cool pink too. I call it Barbie pink. So we're going to put 10 drops of that in there. And then we've got the acid in there. And we're going to start dripping with our burette. There's a valve here until it turns pink and stays pink. And we're done. We don't want to go any further until it just turns pink. When you get close, it's going to start, it'll turn pink and then go away because you've got to be swirling this. So this is a two-person job. One person swirls, the other one drops. Okay? So you need to join with someone. Okay? All right, I'm going to go drip, 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 and then all of a sudden you're going to get pink. Then you're going to read from the burette in milliliters how much it took to get that pink color. Okay, then that's going to be your milliliters. So in this problem up here, it took 23.4 milliliters of base to get that pink color of the acid base neutralization. Okay, so it's all based on acid and bases neutralizing one another. Now, in the stock room, we've got probably 25 indicators. And the one we use 99% of the time is phenolphthalein, the Barbie pink indicator. It's extremely common. Okay, are there any questions about this? Now, you've never seen this before. And there's a lot of parts. Now, your lab will pace you through it. You do one part at a time till you end up with calculating concentration of the unknown acid. Now, lab 15 is to determine the unknown concentration of the base. And then using that for lab 16, then we're going to titrate and see the concentration in milligrams of the vitamin C tablet. So this is going to be your most comprehensive lab of the semester, these two together. That's one reason it's at the end. You're bringing all these concepts together: solutions, concentrations, acid-base neutralization. Yeah. Which, your lab? Yeah, you'll be okay. You're wearing long pants, right? And appropriate shoes. Okay. All right. So no questions about this? All right, let's do another one. Now, on your burette, I said to fill it to zero. You don't have to fill it to zero. It's easier if you fill it to zero. And you're going to use a dropper to get it right at zero as best you can. However, you don't have to start at zero because you're going to get in your data table, you're going to have something called initial volume, final volume. And then you subtract the two. Well, if your initial volume is zero, you don't, when you subtract zero, it's, nothing changes. But if you don't start at zero, then you got to subtract. For this problem, if we don't start at zero, starting at 234 instead of zero. Okay, so we've got our base. Concentration of the base is 0.45. So we've got the initial reading is 234. The final reading is 34.5 milliliters. You subtract the two. Unless it's at zero. So we are looking at so that's the volume of the base. Then we need to convert it to liters. Okay, by dividing it by 1,000. All right, so that's the volume of our base. The volume of our acid is going to put in 25 milliliters. Converted to liters. Okay, and then we know our concentration of sodium hydroxide. So we're going to go back to our just like we did up here. So the concentration of our acid now is equal to the volume of the base concentration of the base divided by the volume of the acid, which is liters cancel, leaves us a concentration. Now it's going to be two sig figs because of the 0.45. So we're going to make this. Now you're going to have one of these on your test. Okay. So how are we doing? Is this making sense? Now, I've got worksheets for you to practice. So let me show you where there are. Okay, so we're going to go to Files. Unit 3. And so these are questions and answers for titration, where there are 5 problems there.
Would you explain the difference between the two equations, one is titration versus dilation? Because it looks like I'm looking over the problems and we're solving for concentration as well.
Yeah.
But I just
It
want to,
uses the same relationship of volume and concentration, because you need to find moles. So it uses that volume times concentration. Yeah, it's exactly the same one.
is it fine? Then what's the difference?
Okay, so dilution, we're starting with an initial and final concentration. Concentration is moles per liter. Moles per liter. But what's the same on the initial and final equals, moles are equal. So then you get moles of initial, moles of final. Those have got to be equal. Then you can calculate the moles of the concentrated to find the diluted mole. Okay, with titration, we're still looking for moles, but we're trying to find the moles of one versus the other, totally different chemicals. But at neutralization, they're equal. So all we're doing is we're using that relationship of concentration times volume gives us moles. So the equation look exactly the same, doesn't it? Yeah. Okay, so anyway, that's one worksheet. I think there's another one as well. I thought there were 2. I'll find another one and post it on here. Okay, I'm also going to post a practice test. I'm going to do that in the lab today. Okay, so any questions about titrations? You have to do some of these. And it'd be good if you could do that titration worksheet before next week. That way, when you come to lab, you'll know what you're doing. Okay? Yeah. Week from today. That's test 3. Okay, I changed the lab schedule to reflect next week's lab being lab 15. Because before it was a dry lab. Uh, no, today we're doing the gases. Next week we're doing 15. When we get back from break, we're doing 16. Okay, that's what I wanted to cover today, is this titration calculation. Now, we're officially done with unit 3 as of today. So we've covered, if you look at the yeah, okay, so this is the study guide for unit 3 I did last week. Okay, so yesterday we talked about ideal gas law and changing conditions with gases. Your lab today is going to go through that as well. Acids and bases, what is an acid? What is a base? That's under qualitative. What's an endpoint? What's pH? Quantitatively, you're going to be able to calculate concentration of acids, concentration of bases, and titration. Solutions, qualitative. How does a crystal of sodium chloride or sugar or whatever dissolves in a liquid solvent? Okay, then quantitatively, you have the relationships of concentration and volume equals moles. And you'll be doing some, how do you mix this up? How do you make this, etc. Okay. Now, and today, again, I'll post a practice test with these 3 in it. Okay. All right. So do you want to start lab early today? Gosh, everyone's raising their hand. Why is that?